welcome you all for 10th standard CBSE tutorials. In previous sessions we have already seen natural numbers, whole numbers, integers, rational number, irrational numbers. Okay, today we will look into that real numbers. In real numbers we need to have some remembering points. What are the remembering points here is? So one here is algorithm. Algorithm means a series of well-defined steps which gives a procedure for solving a type of problem. And the second one is lemma. It is a proven statement. Lemma is a proven statement used for proving another statement. If one statement is there, it is a proven statement to prove the another statement which is used for. And the one is Euclid division lemma. For a given positive two integers a and b, for any given two positive integers a and b, there exist unique integers q and r, satisfying that a is equal to bq plus r, wherein 0 is equal to or less than r and less than b. Let two integers a and b such that a is more than b. Now we'll see the Euclid division lemma method in detail for finding the HCF of the given numbers. The steps here are: let the two integers a and b such that a is more than b. Step number 2 is take the greater number a as dividend and b as divisor. Step number 3, now find the whole numbers q and r as quotient and remainder respectively. Here the statement we can frame here is a is equal to bq plus r. 0 is more than r, equal to r, or less than b. Step number 4 here, if r is equal to 0, b is the HCF of the a and b. If r is not equal to 0, then take r as divisor and b as dividend. Then step number 5, repeat the step 2. Repeat the step 2 till the remainder we get 0. The divisor thus obtained is itself the required HCF of the given numbers. Okay. Now we'll look into prime factorization method. What is prime factorization method? So every composite numbers can be expressed as a product of primes. Every composite numbers can be expressed as a product of primes. By using this, we can find HCF and LCM of given numbers. This method we call it as prime factorization method. Okay. Prime factorization method to find the HCF and LCM of the given numbers. Okay, here there are the practical steps to be followed for finding the HCF and LCM of a 2-digit number or 3-digit numbers. Okay, the step 1 here is find all prime factors of the given numbers. Step number 2 here is the product of least power of each common factor is the required HCF. The product of least power of each common factor is the required HCF. And the product of the greatest power of each prime factor is the required LCM. Okay, here is the least power, here is the greatest power. Least power is the HCF and greatest power is the LCM. Next, step number 3. If p and q are the two integers, then we can say the product of LCM and HCF which is equal to the given numbers. Product of given numbers. HCF of p and q. So p and q are the integers. Okay. HCF of p and q and LCM of p and q which is equal to p and q. The product of p and q. Here the product of 3 numbers. In case of 3 numbers, the product of 3 numbers is not equal to the product of their LCM and HCF. Here in case of 2-digit only, the HCF and LCM of two given numbers is the product of the two given numbers. But in case of 3-digit numbers, the product of three numbers is not equal to the product of their LCM and HCF. However, we can frame a statement here is LCM of PQR. PQR are the 3 digits, 3 integers. LCM of 3 integers, that is PQR, which is equal to PQR, the product of PQR, into HCF of PQR divided by HCF of PQ into HCF of QR into HCF of PR. In case of HCF of PQR, in case of 3-digit, finding the HCF of 3-digit, HCF of PQR, which is equal to PQR, the product of PQR, into the LCM of PQR divided by LCM of PQ into LCM of QR and into LCM of PR. Okay. Let us look into some examples. Comes into the chapter real numbers. Okay. The example number 1 here is, so find the value of the root 2 minus 1 divided by root 2 plus 1. Root 2 minus 1 divided by root 2 plus 1. Let multiply on either side, that is on the numerator as well as the denominator by, so root 2 minus 1 divided by root 2 minus 1. We have taken up multiplication on either side the root 2 minus 1. Here, next step here is root 2 minus 1 into root 2 minus 1, here is root 2 minus 1 to the power 2 divided by. So this is one term and one more term to be multiplied. This is the power 2. Okay, next here is root 2 into root 2. This is to be multiplied by this term. We'll get is root 2 into root 2 is 2. So 1 into 1 is, so minus 1. Which we get it simplified here is root 2. We will again simplify here is as root 2 minus 1 to the power 2 can be 2 minus 1 is 1 only, which can be, I will simplify that as what we have done is a plus b bracket square or a minus b bracket square. I will split the term as root 2 to the power, to the bracket root 2 minus 1, okay, minus 1 to the bracket root 2 minus 1. We get it, root 2 into root 2 is 2 minus root 2, 1 into root 2 is minus root 2, minus into minus is plus, 1 into 1 is 1. Here we get it minus root 2 and minus root 2, that is 2 minus 2 root 2. This is 1 root 2, this is 1 more root 2, that is 2 root 2 and this is plus 1. It can be still simplified as 2 plus 1 is 3 minus 2 root 2 is the answer. Okay, let us look into the second sum. Write 3 by 8 in a decimal form. Okay, 3 by 8. It can be rewritten here as 3 divided by, we can make factor of 3, factor of 8, that is 2 into 2 into 2. 2 into 2 to the 4, 2 is 8. Okay, again it can be 3 by 2 to the power of 3. Okay. Next, we will multiply by 5 to the power 3 divided by 5 multiplied by to the power 3 on either side. Okay. What happens here is 5 to the power of 3 is 5 5s are 25, 25 5s are 125, 125 3s are 375 divided by, so since the base are different, I will multiply here is, so 5 2s are 10, okay, 10 to the power of 3. So it can be still simplified as 375 divided by, so 10 tens are 100, 100 tens are 1000. So it can be rewritten as 0.375, which is the answer for 3 by 8. So 3 by 8 in the decimal form it is 0.375. Okay. Okay. We'll look into the some third one. Find the HCF of 3 to the power 3 into 5 and 3 to the power of 2 into 5. Here we have to have the HCF is the highest common factor. The highest common in these two numbers is one is 3 to the power of 2 and one more is 3 to the power of 2. The highest which is common here is 3 to the power of 2, which is highest and the common among the two given numbers. And one more is 5 and 5 to the power 2. The common in these two cases is, so 5 is the common, that is multiplied by 5. So I should multiply this, and so 3 to the power of 2 is 9 into 5 is, so 45 is the HCF of 3 to the power 2 into 5 and 3 square into 5 square. Okay. Next we will look into the sum number 4. Find the HCF of the two numbers 1656 and 4025 by division method. So we have already seen the points, that is Lemma method for finding the HCF. Here we have to find the HCF of the smaller number and the HCF of the bigger number. Here the bigger number is 4025. We have to division method here is, so 1656. It is as a divisor. What I will take here is, so 1656 I will take it here as 2 multiplied by 2. So I can take it as 2 here is 1656 into 2 is 3312. Okay, I should subtract this. Okay, then here 713 is the remainder in this case. Next, this remainder again we should take this as a divisor. So 1656 and the remainder, whatever we got it, the remainder from this, we have to take this in this case as a divisor and divide the previous divisor here. Next, I will take it 713 into 2, which will be 1426. Okay, I should again subtract this. So we got here is 230 as a remainder in this case. Here is a remainder, here is a remainder. Again, this remainder should act as a divisor for which number? For this number, for 730. In this case, what I will do here is 230 into 3. I will take this as 3. 3 zeros are 0. Okay. 3 3s are 9. 3 2s are 6. 713 minus 690, we get 23. Next, this will become a divisor for the 230. 230. Okay, what I will do here is 223 into 10, which will give 230. So my remainder is 0. So what we have to do is we have to take the bigger number, that is B and A to be treated as A, smaller number, then smaller number to be bigger number to be divided by this one. Keep on doing this unless and until we get 0. Okay, now HCF of 1656 and 4025 is 23. That is 23, we got it here. The last divisor is the HCF of 1656 and 4025. Okay. Now we will look into the sum number 5. Given that HCF of 306 and 1314 is 18. The given data itself is 18. And find the LCM of 306 and 1314 based on the HCF of this. Okay, what we'll have to do is HCF, the given data itself is HCF is equal to 80. Then LCM is equal to, we have to find out, which I say X. Here the first term is, the first number is 306. Okay, and the second number is, second term is 1340. Based on the prime factorization method for finding the HCF and LCM, we have the first term into second term, which will be the product of LCM and HCF. This is the prime factorization method for finding the LCM and HCF. Here the first term given, we will substitute here into 1314, which is equal to LCM. We have to find it now. LCM into HCF is already given 18. Okay, next we will take out the LCM. LCM is equal to, okay, LCM is equal to 306 into 314 divided by 80. Okay, I will take simplification here as 3 6s are 3 1s are 3, 3 10s are 30, 3 2s are 6. Okay, answer here is 102 into 1314 divided by 6, which we get it here is 6 1s are, okay, 6 2s are 12, okay, 6 1s are 6, 6 9s are. Here it can be still simplified as 102 into 219, which will be equals to 22,338. The LCM. LCM of what? LCM of 306 and 1340. Okay.